My name is Malihi with the Fargol Research Group, and this is the second segment in technology of liquid dishwashing products. This segment deals with the mechanism of cleaning of dishwashing liquids. All right. The way dishwashing liquids work is that they loosen greasy soils and keep it suspended so that it can be rinsed away. Once saturated with soil, suds vanish and the detergent's cleaning power is reduced. This process is subject to many variables, thermal energy, mechanical energy, type of soils, type of substrate. So it's a very complex process. There are also different methods of using manual dishwashing liquids. There is neat dishwashing, which concentrated products are put on a sponge. There is dilute method, where product is diluted in the sink and then washing is done. Dip and dab method, and there are different rinsing methods. Variables in manual dishwashing process include soils, different kind of soils. It can be fatty, oily soils, protein, carbohydrates, baked on soil, which is the toughest kind. Different surfaces, metal, aluminum, stainless steel, china, glass, and different kind of plastic surfaces. Also, water introduces variables. Temperature of water can vary from 30 to 45 degrees C. Water hardness can go from very low hardness, around 50 ppm, to very high, above 200 ppm hardness. And the pH. Cleaning efficiency, this is defined as solutions' ability to penetrate, hydrate, disperse, and emulsify different kind of soils, mainly greasy, fatty soils, and which can be accomplished with minimum mechanical energy. So there are three types of energy involved here. There is thermal energy that comes from the warm, hot water, surface chemical energy that is provided by surfactants, and the mechanical energy, scrubbing and basically manual mechanical energy. As mentioned, surface active agents are the most important components of manual dishwashing detergent formulations. These are basically bifunctional molecules. They have a hydrophobic segment, which is mainly a carbon chain, and a hydrophilic segment that is usually a polar group, or anionics is usually sulfates and sulfonates. Key characteristic of surfactants include their orientation at surface and in interfaces to reduce surface and interfacial tension and basically help detachment of soils from surfaces. There are different kinds of surfactants. Anionics are mainly used in dishwashing liquids. Alkyl benzene sulfonate, alkyl ether sulfates are primarily used. In Europe, paraffin sulfonate is also used. In Japan, alpha olefin sulfonates are used. Cationics have no use in dish liquids. Amphoterics and non-ionics are also used to impart the mildness to skin. This is basically how a surfactant works. At very low dilution, it reduces surface tension of water to a minimum And that reduction in surface tension basically is responsible for improve in detergency. We talked about this. The mechanism involved penetration of surfactant into soil, loosening, softening soil, enhancing water absorption and wetting, helping with detachment of soil, emulsifying and dispersing soil in water, and prevention of redeposition of soil on the surface. Efficiency of surface active materials can be determined by tensiometer, and minimum surface tension and critical micelle concentrations are shown here for a number of surfactants: paraffin sulfonate, alcohol ether sulfates, alcohol ethoxylate, and betaines. Also, wetting power of different surfactants are shown here. Paraffin sulfonates have a very good wetting, so does the alkyl benzene sulfonates, and also alcohol ethoxylates. There are several mechanisms involving cleaning. Roll-up relates to basically detachment of oily, greasy soil, solubilization, emulsification, and formation of surfactant-rich liquid phases. Wetting process basically is accomplished by surface active agents in which they basically uh, increase the contact angle of greasy soil on the surface, hence help remove the greasy soils. For particulate soil, initially these soils are hydrated and wetted. Absorption of surfactant eases the detachment of particulate soil from the surface of the substrate. It can be a metallic substrate, glass, or plastic. And finally, surfactants absorb at the surface of these particles, soil particles, impart a negative charge that does not let them attach to each other again or attach to the substrate. And finally, the surfactants form a layer on the surface of the substrate, which is eventually rinsed away. For oily soil, the mechanism is roll-up. Again, surfactants result in an increase in contact angle and go from this attachment, basically a spreading condition, to a spherical condition and eventual removal of oily soil. All this happens because of surfactant absorption on soil, solution interface, soil substrate interface, and substrate solution interface, reducing interfacial tensions and reducing the work required to remove the soil. Here, a schematic shows this detachment of soil. Initially, soil, either greasy or particulate, or usually a mixture of the two, is attached on the surface. Surfactants adsorb on the surface of the substrate and soil and lead to the detachment of soil and emulsification of soil. In foam generation, the primary mechanism is the use of surfactants. Surfactants basically cover the interface between air and water, basically the layers of the soap bubbles, and stabilize those layers, prevent it from bursting. Foams are important in dishwashing liquids from consumer perception point of view. Foam doesn't really contribute to cleaning, but the perception is important. So consumers see long-lasting foam as a surfactant efficiency. They also hide the dirty water. Two factors Destabilize foam bubbles, breaking of surface layer due to evaporation and mechanical force, reduction in layer thickness due to constant movement of a solution at the surface layer. Uh, Anionic surfactants are generally very high foaming surfactants. So are amphoterics, but non-ionics have significantly lower uh, foam volumes.